There are many scenarios in which a nurse may need to convert between two different units. If a doctor prescribes a medication in one unit and the label in the bottle lists a different one, for example, or if a patient can't conceptualize metric units and needs an equivalent household unit for reference. In this video, we'll be going over two different methods for simple unit conversions: conversion factors and dimensional analysis. A conversion factor is a number used with either multiplication or division to convert between one unit and another. The primary question asked in this scenario is this: do we multiply or do we divide? To answer this question, we need to know one crucial piece of information: which unit is larger in size. If the unit you are starting with is larger, you need to multiply. If the other unit is larger and you are starting with the smaller unit, you need to divide. Let's do some simple conversions to practice. Our first problem asks us the number of tablespoons that equals 6 teaspoons. To solve this problem, we'll need to find our conversion factor by recalling an equivalent for teaspoons and tablespoons. In this case, we have two numbers to choose from as our conversion factor: 1 or 3. Given that anything multiplied or divided by 1 is itself, the obvious choice is the number 3. Now, we decide. Do we multiply or divide? Let's look back at our problem. We're converting 6 teaspoons to tablespoons. Are we starting with the larger unit or the smaller unit? Though it may seem obvious that we are, in fact, starting with the smaller unit, there may come a time when you are unfamiliar with the units involved. To find the larger unit, look at the equivalent. The unit attached to the number 1 is the larger unit. Now let's recall our rules, knowing that we're starting with the smaller unit. According to the rules, we should divide. So let's divide our 6 teaspoons by our conversion factor, the number 3. This leaves us with the answer that 6 teaspoons is equal to 2 tablespoons, which is correct. Let's do another example before we move on. Let's say that instead we were asked to determine the number of teaspoons equal to 2 tablespoons. We use the same equivalent and the same conversion factor. But this time we're starting with the larger unit. So according to our rules, we need to multiply. So let's multiply our 2 tablespoons by our conversion factor. We're left with what we know to be the correct answer, that 2 tablespoons is equal to 6 teaspoons. Let's move on to the second conversion method: dimensional analysis. Dimensional analysis is a mathematical equation that we can use to convert between any units, so long as we have equivalents for them. The equation itself looks like this. We have 2 fractions listed here, with the number 1 always placed in the bottom left, and 3 other variables. The first variable is called the given. It is a number and a unit that is given to you by the question. The second variable is called what you're converting from. It is also a number and a unit. The unit will always be the same as the given, but the number comes from a different place. Instead of being provided to you, the number will come from the equivalent you use. The third variable is called what you're converting to. Like the other 2 variables, it is both a number and a unit, but in this case, the unit will be different from the previous 2. This unit is the unit that you will be converting to based on the equivalent you use. The equivalent is also where you'll find the number for this variable. Let's do an example, and let's keep our conversion factor rules in mind and check our work as we go along. Let's say you need to determine how many milligrams are equal to 5 6/10 grams. The first thing we need to do is find our equivalent. In this case, we'll be using this equivalent. 1 gram equals 1,000 milligrams. Now we prepare our equation, writing in the lines multiplication sign and the number 1, leaving the other spaces blank. In this case, I've left the names of the variables here so we have a visual to guide us along. We have all of the pieces we need in order to fill in the variables, and we start with the given. Remember, the given is part of the original question. It's a number and its associated unit. In most cases, a question will only provide you with one full set of information like we see here. The question has two components, 5 and 6/10 grams and an unknown number of milligrams. Only one of these pieces of information is complete. So our given in this case is 5 and 6/10 grams. Now we move on to the next variable, what we're converting from. Remember, this is also a number and a unit, and the unit is always the same as the unit before. So we know up front that this variable will be some number associated with grams. To find the associated number, all we need to do is consult the equivalent, which has two components, 1 gram and 1,000 milligrams. Since we know our converting from variable will be in grams, we can very easily identify the number we need to complete this portion. It's the number 1. Personally, I like to put a line through variables after I've used them so I don't accidentally use them again. So we're going to strike through only the 1 gram portion of this equivalent. Now all that's left is to fill in our final variable, what we're converting to. To fill this in, we're going to refer once more to our equivalent. Remember, this variable is a number and the unit we're converting to, according to this equivalent. Since we've already used up the 1 gram side of the equation, all that's left is the 1,000 milligrams. So that is what we'll use for this last variable. Now we get to the part of dimensional analysis that makes it so incredibly convenient. Since this mathematical phrase has grams in a numerator and in a denominator, we can cancel that unit out. And we're left with only one unit in the equation, milligrams, which is convenient because that's the unit we've been asked to convert to. All that's left to do is multiply across, just like you would with any other set of multiplied fractions. That leaves us with our answer, that 5,600 milligrams is equal to 5 and 6/10 grams. This method is very reliable, and for the sake of accuracy is generally preferred. Just to see if our math is correct, though, let's try to solve this equation using conversion factors. We'll be using the same equivalent that we used for dimensional analysis. First, we need to isolate the conversion factor, which we can see here will be 1,000. Next, we need to know which unit is larger, grams or milligrams. In our equivalent, grams is associated with the number 1, so we know it's the larger unit. That means we're converting from the larger unit, which means we'll be multiplying. 5 and 6/10 times 1,000 is equal to 5,600. So our answer is that 5 and 6/10 of a gram is equivalent to 5,600 milligrams. That means that our answer was correct in our dimensional analysis. Because this conversion is solely within the metric system, we can even use a conversion slider to confirm our answer. We start with the unit we're given and move to the unit we're converting to, remembering that with this conversion slider, that one movement here is equal to 3 movements of the decimal. So this one movement from grams to milligrams is equivalent to 3 movements for the decimal in the same direction. That leaves us with, you guessed it, 5,600 milligrams. Let's do another practice, but instead of staying within one unit system, let's convert a metric unit to a household unit. This question is asking us to convert 41 and 25 centimeters to inches. Let's solve this one using dimensional analysis, and then we can check our work again using conversion factors. Let's start by bringing up our equivalent. Now we can fill in our variables. Let's find our given. The question asks us to find an unspecified number of inches equal to 41 and 25 centimeters. Of the two options, the only complete piece of information is the centimeters, so that's our given. Next, we need to fill in what we're converting from. It has to be the same unit as the given. And we'll find the number by locating that unit in our equivalent. Our equivalent is that 1 inch is equal to 2.5 centimeters, so we'll be putting 2 and 5/10 next to our unit, and crossing out the centimeters half of the equation so we don't accidentally use it again. Finally, let's fill in what we're converting to, which is just the side of our equivalent that we haven't used yet. In this case, that's 1 inch. Now we cancel our units. Centimeters is in a numerator and a denominator, so we can cancel that unit and remove it entirely, leaving us only with inches. Now let's multiply across. We can simplify that. That leaves us with 41 and 25 hundredths inches over 2.5. So we need to simplify by dividing the numerator and denominator by 2 and 5 tenths. That leaves us with our answer that 16.5 inches is equal to 41 and 1/4 centimeters. Let's check our math using conversion factors again, using that same equivalent. First, we find our conversion factor. Our equivalent says that 1 inch is equal to 2.5 centimeters, so our conversion factor will be 2 and 5 tenths. Now let's determine the relative size of the units. Since the number 1 is associated with inches, that means that inches must be the larger unit, and centimeters are smaller. That means we're converting from the smaller unit, which means we have to divide. So let's do it. 41 1/4 divided by 2.5 is equal to 16 1/2, just like we saw earlier. So our math checks out, and 41 and 25 hundredths of a centimeter is in fact equal to 16.5 inches. Use dimensional analysis and conversion factors to convert between any two units. Just make sure that you have the equivalents and remember the rules that govern each method.